Do you see the overlap from the Zoom video?
We see what we see right now is I see it's just a slideshow. So I see the grade
Okay.
slide. So it's like I'm looking at a PowerPoint on a projector.
Okay. Oh yeah, I'm ready.
Whenever you're ready, go.
All right. Hi, I'm Nick Vest, and this is Jesse Cowling. This is Introduction to Mechanical Concepts taught by Mr. Ward, and we're going to be covering steel from the manufacturing processes and materials. Quick overview. Steel plays an important role in everyday life and manufacturing, whether it's in the frame of your car or a steel beam skeleton that supports the tower. It's strong and a versatile material. The presentation will cover various notable steel materials and their involvement in manufacturing, as well as their advantages and differences between each other, and the numbering system used to classify them. Mild steel is the first material I'll be covering. It's referred to also as low carbon steel because it contains a low amount of carbon compared to the other steels there are. Generally, the carbon is under 0.3% in weight, and it gives mild steel increased ductility and allows for easier welding and machining, as well as making it great for piping. However, the low carbon also leads to a lower tensile strength, and it can't be stretched as much as other steels would be able to. It's also very difficult to harden or strengthen. Its high iron content gives the material magnetic properties, but can also cause oxidation if it's not properly coated. And it's commonly made by combining melted iron and coal in a blast furnace. Medium carbon steel, similar to mild steel, but contains more carbon, generally between 0.3 and 0.6%. It's used in many automotive parts, and medium carbon steel is stronger and more durable than mild steel, but still offers some ductility and is around a similar price point. High carbon steel contains the most carbon out of the three main carbon steels, normally between 0.6 and 1.5%. High carbon steel is very strong and extremely durable, often used in cutting tools like chisels and knives and other cutlery. Its increased strength and ability to hold a sharp edge comes with a cost of significantly less ductility and higher brittleness than mild steel.
There's two different types of rolled steel. There's hot rolled steel and there's cold rolled steel. Hot rolled steel is steel that has been roll pressed at temperatures over 1,700 Fahrenheit, making the steel easy to form and work with. The process starts with a large rectangular billet of steel, which is then heated and flattened. The steel is kept at high temperature for a while as it is run through a series of rollers and eventually pushed through rollers at a high speed as hot strands, which may then be cut and stored or spun into coils, depending on their intended use. Cold rolled steel, it is essentially hot rolled steel that has undergone further processing. After hot rolled steel has cooled, it is rolled again at room temperature to better accuratize dimensions and improve surface qualities. Often used to describe finishing processes and applies to sheet metal rather than bars, poles, or tubes, which are drawn. Some of the pros for a hot rolled steel are they're slightly rounded and have smooth edges, and there's very low energy consumption, and there's low cost. Some cons against it are slight deformation during cooling sometimes. For cold rolled steel, some of the pros are that it's smoother, better finished surface with higher tolerances. The surface is usually oily to the touch. It has solid defined edges, and some of the cons are it's a higher production cost than the hot rolled steel, and it requires more energy than hot rolled steel as well.
The purpose of steel alloys. Plain carbon steel, one of the most common steel alloys, contains carbon and iron. However, steel alloys are made by combining carbon steel with other alloying materials to produce elements with different specific properties. These elements can be added in varying proportions and combinations, give certain properties to steels to better protect it from the elements. such as corrosion resistance and to increase hardness. Some of the common alloying elements include chromium that increases hardness and wear resistance, cobalt improves hardness at high temperatures, manganese gives it an increased surface hardness and shock resistance, and tungsten gives it improved heat resistance.
Stainless steel is an alloy containing anywhere from 10 to 30% chromium in combination with low carbon content, giving the alloy great corrosion and heat resistance. Other elements such as titanium, aluminum, copper, nitrogen, and those from the previous slide, among others, can be added to increase corrosion and resistance to specific environments and improve oxidation resistance. Common uses for stainless steel are kitchen sinks, cutlery, cookware, surgical tools, architecture, auto bodies, rail cars, and aircraft. The SAE steel numbering system follows a four-number or digit organization structure. The first two numbers represent the type of steel and the concentration of the major element in the percentiles, with a 1 to 1% or 1 equals 1%, basically like that. And the last two digits represent the carbon concentration to 0.01%.
Okay, conclusion. The 5 main things I want you to walk away with this presentation are the differences between the main carbon steels, the difference between hot and cold steel, hot rolled and cold rolled steel, the purpose of steel alloys, common common advantages of stainless steel, and a basic understanding of the SAE steel numbering system. And this is our work citing. And that's it.
I'm sorry, I was just talking to you guys and I said a whole bunch and you heard none of it because I was.
Oh, yeah, sorry.
No, you guys did a great job. So I'll see you guys again on Tuesday at noon when we will cover the the test review for manufacturing. Make sure that you have your nesting exercise. And for some reason, I did not have the fidget spinner unlocked or visible to you, so that it is visible to you now, so you can start looking at your fidget spinner designs. And those are going to be due next Sunday at the end of the day. Otherwise, we'll see you guys Tuesday at noon.
Okay, thank you.
Have a nice day.
And also, what do you recommend watching the presentations that other people did that we missed yesterday?
Yep, I haven't put those up yet, but I will.
Okay, thank you.
All right, we'll see you guys.